There are seas, mountains, dunes, although not from sand, but from heat-resistant organic matter. And when summer comes to the North Pole, it even rains methane. It's an amazing world. Indeed, we are talking about Titan, Saturn's biggest moon, the second largest moon in the solar system, after Jupiter's satellite Ganymede. It is the only celestial body in the solar system, with the exception of Earth and Mars, for which the existence of liquid on the surface has been proven, and it's the only moon on the planet with a dense atmosphere. The diameter of Titan is 5,152 kilometers, which is 50% larger than that of the Moon, while Titan is 80% larger in mass than Earth's satellite. Titan also surpasses the planet Mercury in size, although it is smaller than it in mass. The force of gravity on it is approximately 1/7 that of the Earth's. Titan's mass makes up 95% of the mass of all of Saturn's moons. Titan conceals many of its secrets, but today we will turn our attention to its amazing landscape. Now, the surface of Titan is composed mainly of water ice and sedimentary organic matter. It is geologically young and mostly flat, with the exception of a small number of mountainous formations and craters, as well as a few cryovolcanoes. For a long time, the dense atmosphere surrounding Titan made it impossible for the surface of the Moon to be seen until the arrival of the Cassini-Huygens space research mission. Scientists suspect that under the ice shell of Titan, at a depth of about 100 kilometers, there is an ocean of liquid water. This is indicated by some irregularities in the oscillations of the Moon in its orbital motion. Photographed by the Cassini in various spectral ranges, the surface of Titan in the tropical latitudes is divided into several bright and dark regions with clear boundaries. Near the equator, on the leading hemisphere, there is a bright region the size of Australia, which is high ground, probably a mountainous area. It was named Xanadu. In general, the surface topography of Titan is relatively level. The variation in height is no more than 2 kilometers. However, local changes of elevation, as shown by radar data and stereoscopic images obtained by the Huygens, can be quite significant. Steep slopes on Titan are not uncommon. This is the result of intense erosion in conjunction with wind and liquid. There are several objects that look like impact craters, presumably filled with hydrocarbons. Many craters may have been buried under a layer of sediment or were quickly smoothed over by intense wind erosion. The surface of Titan in the temperature latitudes is less contrasting. Titan has distinct indications of volcanic activity. However, despite the similarity in the form and characteristics of the volcanoes, it is not silicate-based volcanoes that are at play on the satellite, as on the Earth or Mars and Venus, but what are known as cryovolcanoes, which most likely erupt with a water-ammonia mixture with a touch of hydrocarbons. Unlike the Earth, in the course of the change of seasons, powerful clouds of Titan move a great deal more along the latitudes, while on Earth they move north or south only slightly. Disappearing islands on Titan have also been a huge mystery for years. The largest of them is in the mysterious seas of Kraken Mare. The depth of the seas ranges to several hundred meters. Studies of the sea, Ligia Mare, have discovered an unusual feature: bright island-like objects that appear and disappear in some radar images. Moreover, there aren't any significant waves on these bodies of water. There are two explanations of what they can be: gas bubbles or solid floating formations. It turned out that at the surface the mixture exists in the form of one phase, but at a depth of 130 to 170 meters, the ternary mixture's state changes into a combination of two liquid phases and one gaseous. The solubility of nitrogen in ethane is much lower than in methane. It is emitted as a gas. Chemists estimate the diameter of the average bubble at 4.6 centimeters. This size is apparently enough for them to be visible to the radar. Nevertheless, researchers would like to note that there is not enough data to give an accurate description of the processes occurring in the seas of Titan. For example, the temperature and exact composition of the seas are unknown. More accurate data may be provided by future missions to the Moon. A new target of research is Saturn's moon Titan, to which the Dragonfly mission will be launched in 2026. It's expected that in 2034 the 8-rotor drone will land on Titan, which will receive electrical power by means of a thermoelectric generator. Becoming an eyewitness to these new discoveries will truly be an exciting and amazing time.
Mars, by distance, is the 4th from the Sun, and by size, the 7th planet in the solar system. We have seen the unique landscape of Mars. The extinct Martian volcano, Olympus Mons, is the tallest mountain on the planet, and the Mariner Valley is its largest known canyon, and there is a huge number of impact craters. Mars has a rotational period and a change of seasons similar to the Earth. Nonetheless, relaxing under the palm trees, which don't exist here, isn't going to happen. The average temperature on Mars is minus 40 degrees Celsius. To this very day, we are receiving a huge amount of data, some of which we already want to share as early as in 2021. 1. Before you are the white clouds that occasionally appear in the upper layers of the atmosphere of Mars. And as we know, clouds do not form on their own. For their formation, something is required to help the water condense. For a long time, climate models simply could not explain how they could have formed at this sort of altitude. The process consists of what is known as meteorite smoke, whose burnt residue helps the water vapor condense and turn into small particles of ice. This discovery prompted the thought that the fine dust that rises into the atmosphere after the meteorite smoke may play a role in the creation of Martian clouds, very similar to how glowing noctilucent clouds appear in the Earth's mesosphere. However, on the Tempe Terra, located to the north of the Tharsis volcanic plateau, the probe managed to find what are known as eskers, rather low and very long hills, similar in shape to railway embankments. Eskers, unlike many other glacial landforms, are formed not as a result of the movement of the ice itself, but rather of the meltwater flows which spring out from between the edge of the foot of the glacier and the ground and carve narrow but long channels, tens of kilometers in length. 5. Let's turn our attention to what are known as the sand spiders of Mars. No, they won't eat the settlers for a snack. They aren't that kind of spiders. But some things we know for sure are that Mars, just like the Earth, has its own weather, system of air currents and climate. And these canyons, or spiders, as observations have shown, are constantly increasing in size. What causes them to grow? Actually, Martian sand dunes and deposits of dry ice, the frozen carbon dioxide that cover the dunes, facilitate the formation of these landforms. In the summer and springtime, when the air and soil temperatures on Mars sharply increase, a portion of the ice warms and melts. As a result, the dry ice turns into carbon dioxide. A giant bubble of gas appears under the surface of the glacier, and the pressure in it increases. After some time, it reaches a critical point. The ice bursts open, and the CO2 is ejected into the atmosphere of Mars through the fracture. Together with the gas, a massive amount of sand falls onto the surface of the dust-covered ice, which, due to the high pressure, turns this air geyser into a sort of sandblasting machine, stripping away the surface. Therefore, the cracks through which the gas escapes grow each season and turn into the giant spiders, which can be seen in the MRO, or the Mars Reconnaissance Orbiter images. It's difficult to come to grips with the fact that 4 billion years ago, Mars probably resembled the Earth. That means its vast expanses were most likely covered with a shallow ocean, perhaps several hundred meters deep, but not kilometers, as on the Earth. Clearly, there was water. There is already no doubt about that. However, billions and billions of years passed, and Mars rapidly died, becoming cold and losing almost all of its atmosphere. Astonishing Pluto was discovered by astronomer Clyde Tombaugh in 1930, the ninth in order. When still a planet, it was named in honor of the god of the underworld, Pluto. The planet's orbit takes the shape of an elongated ellipse with a significant slope of 17 degrees to the flat plane of motion of the other planets. A complete revolution around the Sun takes Pluto 247 years, and intermittently, for periods of almost 20 years, it happens to be closer to the Sun than Neptune. Pluto's diameter is 2,374 kilometers. Pluto's mass is almost 6 times less than the mass of the Moon. It weighs 480 times less than the Earth, and its diameter is 2/3 that of the diameter of our natural satellite. However, so far very little is known about how they formed and what is happening in them under the multi-kilometer shell. But all the same, the results of the survey were a real surprise to the mission's directors. No one had imagined that distant Pluto would not look at all like a smooth billiard ball, but would have an extremely complex relief, reflecting the history of its origins. In the new images, Pluto turns out to be covered with recently formed mountains, ice plains, methane ice dunes, and even icebergs drifting through nitrogen. In addition to that, the ice crust of the celestial body is strewn with countless cracks that looked like traces of recent tectonic activity. They were the first indication of the existence of a giant subsurface ocean on this dwarf planet. Soon other evidence emerged supporting the presence of liquid water under the planet's icy crust. But how and when it originated on Pluto remains a mystery to this day. But we now know that at one time, Pluto was originally cold. This means that it grew slowly, accumulating ice material from the outer solar system, and at first there was no ocean on it. Water in liquid form only appeared on Pluto after the core of the dwarf planet warmed up as a result of the radioactive decay of aluminium-26 and gravitational interactions with its satellite, Charon. In this scenario, geologic faults in the celestial body would have retained signs of surface compression. Why compression specifically? The fact is that the heat emanating from the depth of the planet would melt the lower layers of the ice, turning it into liquid water, which, as you know, takes up less space. As a consequence, Pluto's ice crust would have begun to contract, which would lead to the formation of distinctive geological traces. And what have we learned about Pluto's atmosphere and climate? Pluto's atmosphere is predominantly composed of nitrogen, with minor traces of methane, ethane, ethylene, and other gases. It is extremely thin. It has a pressure about 1,000 times less than that of the atmospheric pressure on Earth. Nonetheless, it has great influence not only on the climate, but also on the geology of the dwarf planet. For example, it facilitates the equalizing of the temperatures of the different regions of Pluto, and because of the greenhouse effect created by methane, the temperature of the planet's surface increases. Also, new data have demonstrated that some segments of the surface of the dwarf planet actually have snow caps, which are formed in a completely different way than they are on Earth. If on Earth, we are often able to observe the conversion of clouds into snow on mountaintops since temperature decreases with increasing altitude, then on Pluto there is conceptually the inverse process. Since the atmosphere there becomes hotter as the altitude increases, correspondingly, the physiochemical traits of the process of the formation of snow and snowcaps on Pluto differ dramatically. In this case, calling it methane ice is the most accurate conclusion. And finally, it turned out that the change of seasons on Pluto
occurs not because of the tilt of the planet's axis of rotation as on the Earth, but is due to the elongated orbit. Over the course of a revolution around the Sun, which takes roughly 250 Earth years, the amount of heat received by Pluto changes almost 3 times. As a result, the density of the atmosphere fluctuates significantly. In the long summer, which lasts a little less than half of the Plutonian year, the frozen gases evaporate, and in the winter, they again revert to a solid state. They evaporate from the most brightly lit and warmed areas and settle in colder areas. This process ensures that gases are carried over the surface of the planet and over millions of years have sculpted the most amazing forms of relief. What comes next? New Horizons has raised more new questions for us than it has cleared up old ones. But most unfortunately, no new missions to Pluto are planned for the near future. So it will be a long time before we get new information comparable in value to that which was received from New Horizons.
Located at the center of most, if not all galaxies, are supermassive black holes with a mass of millions or billions of times greater than the Sun's mass. For example, in the center of our galaxy is Sagittarius A, whose mass amounts to about 4.5 million suns. Of the known black holes, the one with the smallest mass is only 5 times more massive than our star, but 100,000 times more compact. The diameter of some black holes is no more than the expanse of a large city, but the weight of such a munchkin is like 5,000 suns. The radius of others is comparable to the radius of the Earth, but their mass is 6 million times greater than that of our planet. It simply gets lost against the background of, say, the hole in the center of the Messier 60 galaxy, which has a mass of 4.7 billion suns. The class of ultramassive black holes begins at around this mass, the largest of which are made up of even as many as 4.5 billion suns. But even they seem to be cosmic infants. Currently, the largest known black hole is the Ton 618 quasar, which has the mass of 66 billion times the mass of the Sun. It is located near the North Pole of the galaxy, in the constellation of Canis Venatici, the hunting dogs. The Ton 618 quasar is believed to have an accretion disk of hot gas orbiting the giant black hole at the center of the galaxy. The quasar is estimated to be 3.18 gigaparsec or 10.37 billion light-years away. The emission lines in the spectrum of Ton 618 are usually wide, which tells us that the gas in the accretion disk is moving at very high speed, about 7,000 kilometers per second. The galaxy, in the center of which the quasar is located, is not visible from Earth due to the brightness of the quasar itself. Its absolute stellar magnitude is 140 trillion times greater than that of the Sun. It is precisely because of this that the exact mass cannot be determined. What can't be said about this new challenger, which has the name Holm 15A? Holmberg 15A is a Type CD supergiant elliptical galaxy that is located in the Abell 85 galaxy cluster in the constellation of Cetus, about 700 million light-years from the Sun. The galaxy of Type CD is a subclass of the giant elliptical galaxies of morphological class D. Such galaxies have large stellar halos and can be found near the centers of some large galaxy clusters. They are often considered as potentially the largest representative of galaxies in the universe. Holmberg 15A was discovered in 1937 by Erich Holmberg. The galaxy became famous after it was announced that it had the largest of all observed galactic cores, sprawling about 15,000 light-years in expanse. But then the discovery was refuted. Now Holm 15A is taking the lead again. The fact is that the Abell 85 cluster has its velocity dispersion in a dark halo of about 750 kilometers per second, which can only be explained by the presence of a supermassive black hole with an immense mass of at least 170 billion solar masses. Although the halo of dark matter is not subject to this kind of scaling, but the evolution of a black hole and dark matter has nothing to do with baryonic matter. Notably, among known objects, this is one with the heaviest supermassive black holes. This classic case tells us that the main component of the galactic core is a supermassive black hole with a mass of about 40 billion solar masses and a radius of about 790 astronomical units. By comparison, Pluto is located at a distance of about 39.5 astronomical units away. However, according to the data, the gamma radiation from the object is so extensive that some researchers estimate Home 15A at 310 billion solar masses. How is it possible? Let's try to figure out this galactic mystery. It became obvious from observation that the distribution of stellar orbits was shifting more and more towards tangential motion inside the core. However, the displacement is less than in that of other elliptical galaxies with cores. This tells us that in earlier time there was a merging of galaxies with black holes. Astronomers have detected that the observed magnitude of tangential anisotropy and the shape of the light profile are consistent with a formation scenario where Home 15A is remnant of the merger of two supergiant black holes. And now the masses of black holes in galaxies with cores, including Home 15A, are proportionally scaled inversely with the brightness of the star's central surface and the density of the mass, respectively. That is precisely why black hole Home 15A has taken the position as one of the largest and hungriest supermassive black holes. The new estimate of its size is from 40 to 310 billion solar masses, and its rate of accretion of matter is estimated from about 8,000 to 45,000 times more massive than the black hole in the center of the Milky Way. If the black hole in our galaxy were to accumulate that much matter, it would have to mercilessly swallow 2/3 of all the stars in the Milky Way. Further research will reveal the secrets of this object, but no matter what, the Home 15A black hole is the heaviest among all that have been discovered thus far.
One of the places in the solar system that is worthy of notice and examination is located at an average distance of 250 million kilometers from us and stretches out for more than 1 astronomical unit. That is to say, the distance of the Earth from the Sun. This region is located between the orbits of Mars and Jupiter. As you may have already guessed, we are talking about the asteroid belt, a place where there is an accumulation of a variety of small celestial bodies of every possible size and shape. On May 3rd, 2011, a probe took the first photograph of Vesta from a distance of just over 1 million kilometers, after which an active phase of studying this asteroid began. By June 27th, the craft had slowed down, approaching closer to Vesta all the time. And after another month, having already made almost 2 revolutions around the Sun, the craft reached Vesta and switched to an orbit around it at an altitude of 16,000 kilometers. All of July, the craft was engaged in photographing of the surface of Vesta. The probe confirmed just how large the Rhea Silvia crater in Vesta's southern hemisphere is, about 500 kilometers in diameter and 19 kilometers deep. The spacecraft also revealed that the mountain in the center of the huge crater, which the Hubble telescope had once captured, is more than 2 times the height of Mount Everest and is the second tallest mountain in the solar system, taking a back seat to the Martian Olympus. Upon closer inspection, the probe found a second large impact basin, now called Venenia, that is partially covered by the younger Rhea Silvia basin. These two impacts changed the surface of Vesta and probably almost destroyed it. It remains a mystery how Vesta was able to survive such an extraordinary cataclysm. It is probable that numerous Class V asteroids, debris from the impact, were scattered in all directions. Giant impacts have created dozens of gorges encircling Vesta's equator that were revealed in the probe's images. Some of these canyons rival the Grand Canyon in size, reaching 465 kilometers in length and 4 kilometers in depth. The probe's data also reveals that the massive impact formed Rhea Silvia a mere billion years ago. Thus, the surface of the southern hemisphere looks younger than the northern, where a tremendous number of craters have been preserved. Previously, researchers thought Vesta was a substantially dry object, but the Dawn space probe detected water-rich minerals on Vesta's surface that are associated with carbon-rich material. These materials were presumably taken to Vesta by asteroids or comets from the outer solar system that is richer in volatile substances. On September 5, 2012, having completed an extended mission, the craft broke free of Vesta's orbit and headed toward the next object of research, Ceres, a transition which took 2.5 years. On March 6, 2015, having traversed a total of 4.9 billion kilometers at a distance of 60,600 kilometers from it, the craft was captured in the dwarf planet's gravitational field. And in early June, at a distance of 4,400 kilometers from the surface, the first photographs were already obtained. While the Vesta observations broadly supported the existing hypothesis and provided more details to fill in the gaps, less was known about Ceres. In fact, most of what we now know about the dwarf planet was provided by the Dawn spacecraft. Initial calculations suggested that Ceres might be separated into layers, although the composition of these layers was unknown before the probe. Given a low average density, Ceres was expected to have a large amount of water ice under its surface. However, the probe's measurements have confirmed that Ceres is actually composed of a rocky core and a crust of water ice, covered by a dusty outer layer. Dawn also uncovered evidence of the presence of clathrate hydrates, a gas trapped in the crystalline structure of the water molecules that makes the amazing strength and low crust density of Ceres possible. While a large portion of Ceres is relatively smooth due to its semi-liquid subsurface layer of ice, the spacecraft found a large mountain that it wasn't able to see previously. This mountain is about 4 kilometers high and is called Ahuna Mons. Its well-defined domed shape, similar to volcanoes on Earth, suggests that it was likely formed due to cryovolcanic activity. Although cryovolcanism may exist in other icy worlds, Dawn's observations make Mount Ahuna the closest known cryovolcano in the solar system. Other observations by the Herschel Space Observatory have shown small amounts of water vapor around several portions of Ceres, which suggests that it may have a weak atmosphere or even ongoing cryovolcanic activity. The probe revealed that this gas could be due to solar particles colliding with the water ice on Ceres, which is then released as vapor, resulting in a temporary, weak atmosphere. Spectroscopic data from Dawn also confirmed the presence of ammonia on the surface of the dwarf planet. Conditions in the main asteroid belt are too warm for ammonia to form, which requires much colder conditions, and which raises questions about its origins. Ceres could have formed much further away in the colder outer portion of the solar system before migrating to its current position, or ammonia could have been brought to Ceres by celestial bodies from the outer solar system. The spacecraft also confirmed the presence of carbonates on Ceres, which had been detected 10 years earlier using telescopic data. A great quantity of them once again confirmed the existence of an ocean early in Ceres' history. This dwarf planet may even be warm enough to have a small amount of liquid water remaining below the surface. It's astonishing that for 2 centuries the dwarf planets Ceres and Vesta appear to be no more than dim points of light among the stars, until the Dawn mission provided us with detailed investigative portraits of these two complex and fascinating alien worlds.
The universe of Dune, or the Duneverse, is a fictional universe that was conceived by the writer Frank Herbert and depicted by him in the Chronicles of Dune series of books, which was recreated in a number of film adaptations. It's possible to discuss the Dune universe for hours and hours. However, we will focus on the most awesome creation of the author, both in size and in fame, the sandworm. It may be considered to be the signature element of the Herbert saga. The worm, infamously known as Shai-Hulud by the inhabitants of the desert, is not merely a giant creature of Arrakis, but is also a philosophical symbol. In John Schoenherr's illustration for the first magazine publication of Dune, 1965, the worm's mouth consists of 3 parts, though it is not specified anywhere in the novel that the creature's jaws are arranged in such a manner. The artist later created several cover designs in the same vein. The idea was adopted by the designers of David Lynch's 1984 screen adaptation. As for obvious reasons, we won't be seeing large sandworms on our planet, furrowing through the Sahara or the Atacama Desert of Chile, and you can be confident it's for the best. But nobody knows what the chances are of finding a creature in deep space that resembles the creation of the science fiction writer. We propose taking this topic into consideration in greater detail, and to answer the question, could the worm Shai-Hulud possibly exist in reality? To begin with, let's clarify what this giant crawling creature is. Now then, according to Herbert's description, the sandworm is composed of 100 to 400 individual segments enclosed in a thick, silvery gray, leathery shell. Each of the segments has its own primitive nervous system, so it is almost impossible to kill the worm. Even if one of the segments is destroyed, the other parts will take over its functions. Sandworms are enormous, 400 meters in length, and the largest individuals exceed 2 kilometers. The mouth of the worm measures 80 meters in diameter. Just imagine a huge mouth the size of a 26-story building, surrounded by a multitude of sharp teeth. Yes, indeed, Shai-Hulud is every fisherman's worst nightmare. But the most distinctive aspect is that the worm from Herbert's universe is not a member of the animal kingdom, but a silicon-based life form that fears water. All living creatures we know have common basic features. They grow, reproduce, respond to environmental stimuli, are able to adapt, and sometimes change. In addition, they have a common basis for all biochemistry. They are made of long chains of carbon molecules that use water for metabolism and energy. But it is possible that a non-carbon-based life form exists somewhere, and that such a life form would be very different from what we are used to. The ability of carbon to form long chains makes it an ideal base for the building of sufficiently complex molecules that the body requires to carry out vital functions. Yes, carbon is great for forming complex molecules, but it's not the only element in nature that can do it. There is also silicon, which sits under carbon on the periodic table of elements. This tells us that theoretically, such a life form is possible. In addition, if a sandworm generates oxygen, then the question arises, what does it use as a source of energy? The Milky Way is a relatively medium-sized galaxy which has nevertheless been able to provide a home to about 1 billion planets. Each of these worlds possesses its own unique features and characteristics that are sometimes radically different from those we are used to seeing on Earth. One of these unusual worlds could be a rocky planet that orbits 4 stars at once in the same system. Between 1.5 and 2 astronomical units from the center of the system, meet HD 98800. It is a multiple system of 4 stars located in the constellation Crater, approximately 150 light-years from us. What can such a world signify? What kind of phenomena can occur on this planet? A bit later, we will definitely be imaginatively transported to this extraordinary world. Yes, in space there are more complex star systems with 2, or even more rarely 3 stars, which spin around each other in complex orbits. However, this new discovery is proof that this is not the limit. A group of astronomers were able to detect a system in the universe with 4 stars. Amazingly, all this time, it was hiding a mere 146 light-years from us. Instances of systems that consist of 4 stars are incredibly rare. However, the uniqueness of this object is further enhanced by the fact that HD 98800b has a protoplanetary disk. Using the Spitzer Space Telescope, astronomers discovered that it is composed of 2 belts. The outer belt is separated from the center of a double star by 5.9 astronomical units, almost the same distance separating Jupiter from the Sun. Researchers suspect that this belt is made up of comets and asteroids. The inner belt is located at a distance of 2 astronomical units from the center, as Mars is from the Sun, and it looks like it is formed of fine dust. This kind of division of the protoplanetary disk into sections usually occurs during the formation of a planet, but in this case it came about most likely for another reason, under the influence of the gravity of neighboring mate HD 98800a. How is it possible? The fact is that in most systems it is aligned in respect to the main star. For example, in a solar system, all the planets and most of the asteroids spin approximately on the same plane with the Sun, but this does not apply to HD 98800. It has a disk of gas and dust that is positioned at a right angle to the central stars. This is the first system that is known to us with a perpendicular disk, and such an anomaly promises many more astonishing discoveries. Presumably, if astronomers manage to find other similar older systems, it will be possible to observe planets spinning in strange orbits at all sorts of angles. In turn, this might lead to the formation of new types of planets still unknown to science. However, another scenario is also possible. In such conditions, planets simply cannot form from a protoplanetary disk. The search remains to be continued. In space, there are still many curiosities unknown to mankind. On the other hand, we now understand that planetary formation can, at the very least, begin in these polar circumbinary disks. If the remaining portion of a planet's formation process can occur, there may be an entire population of displaced near-Earth planets that we have yet to discover, with such things as odd seasonal variations. But although planetary formation may begin, it is unclear to what extent planets can form and remain stable in such a seemingly chaotic system. However, if planets were to exist, the view from one of them in a system like this would be amazing. A hypothetical observer would see a bright streak rising from the horizon across the entire sky. From time to time, stars will pass across it. And since the system consists of 4 celestial bodies, a total of 4 suns would be visible in the sky. Because of this, such a planet would have an intricate system of change of seasons, which couldn't be compared with the Earth seasons of the year. An exoplanet that is about 1.35 times the size of Earth and 8 times more massive is orbiting the brightest star in the system, and in doing so receives 5 times more solar radiation from its star. The researchers calculate that the detected object will make a transit all the way across the front of its star, allowing observers from Earth to see the barely perceptible reduction of the light emitted by the star. The incredibly powerful effect of the 4 celestial bodies is literally tearing this planet apart. And the extremely high temperatures and high levels of radiation make this place absolutely unsuitable for the emergence of biological life. Nowadays, thanks to technology, research is even more productive. Evidence of rainforest growth in Antarctica was obtained from a core sample of sediment deposit taken from the seabed near the 90-million-year-old Sosnovyy Ostrov Glacier. During the first stage, the team discovered a fascinating dense network of roots that spread throughout the entire layer of soil, which was so well preserved that not only could countless traces of pollen, spores, and the remains of flowering plants be seen, but even individual cell structures could be distinguished. New evidence has shown that the ancient polar landscape wasn't merely comprised of temperate forests, but temperate tropical rainforests. This means that the climate of the present ice-cold continent was not just temperate then, but substantially warmer that had previously been assumed. Antarctica was a completely different world. It was alive and flourishing in every sense. In addition to the dense and rich vegetation, here various animals, herbivores, omnivores, and carnivores could be found. Among them were also arboreal forms of animals by all appearances, the same as Marumbiothermium glacialis, a small marsupial, something resembling a mouse or a possum. Perhaps small sloths that looked very similar to modern-day ones could be encountered on the branches. Among land animals, the most numerous were representatives of the Sparnotheriodontidae family of mammals, a group of extinct South American ungulates or hoofed mammals that somewhat resembled horses. Judging by the structure of the teeth, they were herbivores and reached a body mass of up to 400 kilograms. Also on land, one could come across flightless or cursorial birds. One was ostrich-like, and the other carnivorous and probably quite dangerous. Along the shores of the ancient Antarctic Peninsula, one might run into king-size penguins, and in the sky, falconiforms, falcons and caracaras. In the lakes, temnospondyls waited for prey. They were giant crocodile-like amphibians. For example, Antarctosuchus pallidon. Reptiles of all kinds roamed the land. Impressive, massive predators, a small lizard-like insectivore, Prolacerta, and of course, dinosaurs. It was not just a Jurassic Park, but a whole continent. The most exotic of them was the Cryolophosaurus ellioti, the ice crest lizard. The narrow skull measuring 65 centimeters, with a huge mouth studded with sharp teeth, could have swallowed a slow-moving person, if of course there had been any at that time. He lived on the dry land about 200 million years ago, as did many others when Antarctica was free of ice. Another interesting creature was the Glacialisaurus, a sauropodomorph, and distant relative of the famous giant long-necked sauropods. However, the Glacialisaurus was much more modest in size. In all likelihood, it averaged 7.6 meters in length, besides weighing significantly less, 4 to 7 tons, which permitted it to rise briefly on 2 legs. Who would have thought that 90 million years ago, near the South Pole, the average air temperature in the summer was 19 degrees Celsius, that it was a tropical, green world, rich in flora and fauna. Now these are cold lands, similar to Mars. So what happened? What sort of climatic occurrence could have prompted such global changes? A giant meteorite? Maybe a great worldwide flood? Or perhaps the expansion of the Tasman Strait between Antarctica and Australia, which in previous geological epochs formed a single continent? No matter whatever happened, a thriving world came to an end. A new era had arrived, the era of the Ice Ages. And as it seems, after millions of years, this is normal for planets of the same type as the Earth. Who knows what cold worlds hundreds of light years away from us are hiding under a thick layer of ice. And if there are only 32 or even fewer settlers, the odds leave them no chance at all, 0%. Perhaps the descendants of the original crew will reach Proxima Centauri, but by that time, they will no longer be able to establish a sustainable colony. But this poses the question, but what if we use cryonics or suspended animation? This is a type of hibernation that can be beneficial in helping the travelers to conserve emotional resources and avoid burnout. It is possible, but not for long. In fact, for much shorter than we think, since this sort of hibernation carries risks, even if people go into it for several months and not years. The consequences may not be reversible, and from what was a strong team, all that will remain will be exhausted and depressed travelers. Therefore, we're back to the old scenario. So having left the Earth behind, the 98 space travelers will give birth to children, and they to grandchildren, even during the lifetime of the first generation. So judging by the calculations, the maximum population on the Ark could reach 500 people. And this means that the colonists will have to provide themselves with food on their own. In other words, grow it directly on board the ship. But how much food do they need? After all, the size of the ship depends on this, and therefore the energy required to move it. These calculations require taking not only the size of the crew into account, but also the average age of the spaceship's inhabitants, their height, weight, and level of physical activity, in order to understand how many calories they will each need annually. If the ship is constructed in the form of a rotating cylinder, so that the centrifugal force provides artificial gravity, then the height of the agricultural compartment should be 320 meters, with a radius of 224 meters. Europa is the biggest moon of Jupiter, with a huge ocean beneath the surface. The satellite's water under a huge layer of ice does not freeze because of the hot core of Europa, which is heated by Jupiter's gravity. This became known in the early 2000s thanks to the Galileo probe, which detected marks of an electrically conductive liquid under the surface of Europa. It also discovered that the surface is made of ice and that it's one of the smoothest in the solar system. It might seem that this is where our knowledge ends, but this is not true. Over the past 20 years, and especially recently, we have learned a lot of exciting details about this distant satellite. We offer to ponder on some of them and reflect on to what degree this distant world can be alive. So Europa, also known as Jupiter 2, is the sixth moon of Jupiter, the smallest of the 4 Galilean satellites. It was discovered in 1610 by Galileo Galilei. Over the centuries, more and more comprehensive observations of Europe were made with telescopes, and since the 70s of the 20th century with flying spacecraft. Europa is slightly smaller than the Moon. With a diameter of 3,122 kilometers, it is the 6th in size among satellites and the 15th among all objects in the solar system. Water entered the atmosphere at a rate of about 2,360 liters per second. If the dwellers of Europe were in that stream, that would have been their last attraction. The good news is, those inhabitants who would manage not to be blown to the outer space would be very easy to find, as the surface of Europe is one of the flattest in the solar system. The tallest formations that can be found here are merely several hundred meters. If we take a close look at Europa's surface images, we will see signs of endogenous geological activity, such as lines, lenticles, bumps and pits, and the so-called Connemara chaos below the center. The high albedo of the satellite indicates that the surface of the ice is pretty clean and young. It is believed that the cleaner the ice on the surface of the icy satellites, the younger it is. Let's also pay attention to the plains. Smooth plains can be formed by the activity of cryovolcanoes, which erupt to the surface, filling areas with spreading and hardening water. From Europa's orbit, we can see a chaotic relief that has different geometric shapes. We can also observe areas which are dominated by lines and stripes, ridges, usually doubled, as well as impact craters. Their number is small. There are only 40 named craters over 5 kilometers in diameter, which suggests that the surface is relatively young, from 20 to 180 million years old. So Europe has high geological activity. The spectral analysis of the dark lines and spots of the structure shows presence of salts, magnesium sulfate in particular. The reddish hue allows to assume the presence of iron and sulfur compounds as well. Apparently, they are contained in the ocean of Europa and are ejected to the surface through clefts and then freeze. In addition, traces of hydrogen peroxide and strong acids were found. For instance, there is a high chance that Europa contains sulfuric acid hydrate. Let's land on that interesting object. As it turns out, it's not that easy. The thing is, Jupiter's moon Europa is surrounded by a region of sharp ice needles, which stretches along the entire equator and is extremely dangerous for space probes to land on. Ice needles, also known as kelgospores in Europa, can reach up to 15 meters in height. Large as they are, these structures still cannot be seen on the images of Europe available to us so far. A few careful maneuvers and we landed. Phew, we managed not to damage our spacecraft by this gigantic icicle. The incredible view of Europe opens to our eyes. Its surface is very cold compared to the Earth. The temperature here is 150–190 degrees Celsius below zero. But that is not the main thing to worry about here. The radiation level on Europe is extremely high, as the satellite's orbit passes through the powerful radiation belt of Jupiter. The daily dose of radiation here is nearly 1,000,000 times bigger than on Earth. This dose is enough to cause severe radiation sickness. But no worries, we have a proper radiation protection. At least we hope so. Well, with this in mind, we are sending a tunnel robot with a nuclear reactor into the deep of Europe that could drill ice while collecting ice and water samples and sending information to the surface via fiber optic cable. Surprisingly, Europe has several layers of ocean, separated by different types of ice formed at different depths and under different pressures. It is likely that in each of these layers, different life forms might be found. Species that have adapted to the particular conditions of the ocean stratum may exist. However, if these life forms turn out to be unlike anything we have seen on Earth, it might be difficult for us to recognize them. And besides, we might not find life there at all. But these thoughts wouldn't stop our curiosity, would they?
More than 40 years ago, the Voyager space probe, exploring the vicinity of Jupiter, took the first photographs of the bright yellow surface of one of the moons of the giant planet Io, the most volcanically active world in the solar system, with hundreds of volcanoes, some of which erupt lava fountains up to 200 kilometers high and higher. Even then, it was clear that this was an extraordinary, ever-changing world. Besides, it was the Voyager that, for the first time, managed to document Jupiter's radiation belt, which passes right across the line of Io's orbit. It is entirely because of such unfortunate positioning that the level of radiation from the giant planet on its nearest satellite is 1,000 times stronger than the level of radiation on the Earth's surface, which makes finding a person on Io simply impossible. Or possible, but not for long, and ill. Thanks to the data collected by spacecraft such as Voyager 1 and 2, Galileo and New Horizons, we have learned a great deal. But at this very moment, the Juno spacecraft is there, and its data has tremendously expanded our understanding of this hellish place. In fact, Io is slightly larger than our Earth's moon, a mere 5%, and orbits at a distance of just over 400,000 kilometers from Jupiter. This satellite is always pointed at one and the same side of its planet, making a complete revolution around it in 42.5 hours. But the most unusual and exciting thing that the Juno probe registered on the moon of Io was its surface. The tremendous quantity of heat inside the moon, which keeps most of its subsurface crust in a liquid form, seeks any accessible outlet to the surface in order to relieve the pressure. As such, Io's surface is constantly regenerating itself, filling any impact craters with lakes of molten lava. It is assumed that the composition of this material is predominantly molten sulfur, its compounds, and silicate rock, which better accounts for an apparent temperature which may be too high. Sulfur dioxide, incidentally, is the primary component of the satellite's atmosphere. Although it is so extremely thin and low in density that, in fact, it is more correctly referred to as an exosphere, which is filled with volcanic gases. The volcanic atmospheric discharges do not contain water and water steam. Thus, being without water, Io significantly differs from the other satellites of Jupiter, the colder Galilean moons. Io's colorful and bright surface appearance is the result of the rigorous work of the volcanoes, which emit various substances in the form of sulfur, dioxide, and silicates. A frosting of sulfur dioxide coats much of the moon's surface, coloring its regions white or gray. In many of the regions, sulfur is also visible due to its yellow and yellow-green color. At mid and high latitudes, radiation is usually broken down by the stable octatomic cyclic molecules of sulfur, as a result of which Io's polar regions are colored in a reddish-brown tint. There are no less than 400 formidable volcanoes on Io, and moreover, about 150 can be active at the same time, generating veritable chaos on the surface. Flows of basaltic lava are a common sight in this place. Magma bursts forth onto the surface through inclines on the bottom of pateras, which are formations with a flat bottom and steep walls, or through the cracks in the flat bottoms, creating numerous wide lava flows. During exceptionally large eruptions, such lava flows can stretch for hundreds of kilometers. As a result of volcanic activity, sulfur dioxide in the form of gas and silicate matter in the form of ash rise to a height of up to 200 kilometers into outer space in the form of a kind of radiation umbrella, and after falling, they color the region red, black, and white. One of the largest volcanic depressions on Io is Loki Patera. With a diameter of 250 kilometers, it is partially filled with molten lava and covered with a hardened thin crust. Similar lakes are directly connected with the magma reservoir located below them. And since the solidified lava is denser than the molten lava below, this crust can sink, increasing the thermal emissions of the volcano. During an eruption, the wave from the sinking crust spreads across the Patera at a rate of about 1 kilometer in 12 hours, until the entire lake is again crusted over. Besides volcanoes, there are also mountains on Io that were formed due to the collisions of layers of the lithosphere, the satellite's hard crust. In those places where stone slabs press heavily against each other, massive cliffs have risen from the depths in exactly the same way that mountains appeared on our Earth. Apart from mountains and volcanoes, Io's surface appears to be very smooth, with only a few meteorite impact craters on it. Another amazing characteristic of Io is the dunes, ribbon-like formations that are visible near the volcano Prometheus. It is believed that the hot lava erupting from volcanoes comes into contact with patches of frozen sulfur dioxide and causes it to release heat as a gas. It then expands violently, creating a temporary wind on the surface, enough to throw grains in the form of sand and create dunes. The space probe Juno made the first of 9 flights to Io that are planned for the next 2 years. During 2 of these flybys, the device will be able to fly to a very close distance from this satellite of Jupiter, about 1,500 kilometers. The spacecraft will make these 2 close flybys of Io on December 30th, 2023 and February 3rd, 2024. At that time, Juno will study how volcanic eruptions interact with Jupiter's powerful magnetic field and influence the occurrence of polar aurora borealises. Io is arguably one of the most captivating and extraordinary moons of which we know. In addition to being the 4th largest moon in the solar system, it is also the densest of those known. Its bright, multicolored surface is the most volcanically active in the solar system.
During transit, some of the star's light passes through the exoplanet's atmospheres, transformed by the atmosphere's chemical composition. This has given astronomers the opportunity to remotely study the climate of terrestrial worlds outside the solar system. And this is important because TRAPPIST-1 worlds are the most optimal worlds available to us today. They provide the first opportunities for humanity to detect signs of biology beyond the solar system. During transit, some of the star's light passes through the exoplanet's atmospheres, transformed by the atmosphere's chemical composition. This has given astronomers the opportunity to remotely study the climate of terrestrial worlds outside the solar system. And this is important because TRAPPIST-1 worlds are the most optimal worlds available to us today. They provide the first opportunities for humanity to detect signs of biology beyond the solar system. Their initial discovery was made with a small telescope. A little later, exoplanets were discovered with the TRAPPIST-Spitzer and full telescopes. Thanks to the transit signals, it was possible to measure orbital periods and calculate their sizes. The exact transit times of exoplanets also makes it possible to measure their masses, which made it possible to know the density and therefore the properties of the bulk. Astronomers have found that exoplanets conform to a rocky composition and that their sizes and masses are comparable to those of Earth and Venus. Relying on data from the distance of exoplanets to their star and the temperature of the star itself, the researchers were able to conclude that some of them receive the same amount of light as many of the planets in the solar system. From Mercury to Mars, the James Webb Space Telescope has taken its first look at a long-awaited target, the atmospheres of 7 Earth-sized planets orbiting the star TRAPPIST-1, just 39 light-years from Earth. All 7 planets are in or near the habitable zone of their star and could have liquid water in one form or another. For astronomers, this is perhaps the best-known laboratory for studying planets outside the solar system for their suitability for life. Finally, the James Webb Telescope has set its eyes on these distant worlds. At the outset, it is worth noting that the telescope has confirmed that of the 7 known exoplanets in the TRAPPIST-1 system, 3 are in the habitable zone. Planets D, E, and F are the 3rd, 4th, and 5th exoplanets. According to the measured density, TRAPPIST-1, the first from the star, may either have a small nucleus or, more likely, contain a significant fraction of water or other volatiles in its composition. In view of the too high surface temperatures of the first two exoplanets, the maintenance of water in liquid form there is highly unlikely. The fifth exoplanet, F, has a fairly low density and may be an ocean planet with space tangents in its interior. By the way, to date, it is believed that the habitable zone may be wider if we consider volcanic hydrogen as a potential greenhouse gas, contributing to the increase in climatic temperature. The telescope also saw some similarities with Centauri Proxima, namely that the X-ray emission of TRAPPIST. One system approximately corresponds to the X-ray emission of Proxima Centauri, and the ultraviolet radiation produced by hydrogen atoms from the chromospheric layer of the star is already 6 times less than on Centauri. For this reason, the two closest exoplanets to the star, TRAPPIST, ONEB, and TRAPPIST, WNEC, could have lost their atmospheres and hydrospheres in a time span of 2 to 3 billion years if their initial masses were similar to Earth's. However, replenishment of atmospheric hydrogen and oxygen may occur through a reaction in which molecules of chemical compounds are broken down by photons if the planets contain a lot of water in one form or another in their composition. Currently, the James Webb Telescope has studied the exoplanet TRAPPIST, ONEB, in more detail, where signs of a high-density atmosphere of the closest planet to the star are not detected or optically thin. Further observations showed that this exoplanet receives 4 times more radiation than Earth from the Sun and is in tidal capture. The temperature of the day side of the planet was estimated with a maximum of 260 degrees Celsius, according to telescope data. And most likely, the heat is not being distributed from the day side to the night side to the night side. Also in the new study, there's already data from a second rocky exoplanet, TRAPPIST, WNEC, which is also in a tidal lock. The planet is interesting because it could be, in fact, a twin of Venus, since it's about the same size and receives the same amount of radiation from its star, but still not as harsh because it has a daytime temperature of about 106 degrees Celsius versus Venus's 420 degrees. And yet, it still gives you an aggressive tan. Although these first measurements do not provide definitive information about the nature of TRAPPIST, WNEC, they help narrow down the range of possibilities. The results are consistent with the exoplanet being essentially a rock consisting of caves and rocks, with no atmosphere and no living aliens, but still not as harsh because it has a daytime temperature of about 106 degrees Celsius versus Venus's 420 degrees. And yet, it still gives you an aggressive tan. Although these first measurements do not provide definitive information about the nature of TRAPPIST, WNEC, they help narrow down the range of possibilities. The results are consistent with the exoplanet being essentially a rock consisting of caves and rocks, with no atmosphere and no living aliens. The James Webb Telescope is currently studying galactic nebulae and black holes, but it also has another important goal. The star system LP 791, 18 is 89 light years away in the constellation Cratera and has at least 2 planets. The system was originally found by ground and space telescopes, TESS and Spitzer. By observing the orbit of the Earth-sized planet, it was found that the surface has volcanic activity, which could lead to the existence of an atmosphere, thanks to which water can condense. Moreover, the planet is on the inner edge of the habitable zone, which is neither too hot nor too cold for water in liquid form to exist, not only in the atmosphere, but also on the surface. In the same star system, there is another planet, ELP 791, 18, a more massive and larger gas giant, which in turn exerts a significant gravitational force on the Earth. Like planet, the gravitational force also slightly deforms both the planet itself and its inhabitants, because of which it is observed high volcanic activity. Similar processes occur on one of the moons of Jupiter. Researchers have already received approval to study the atmosphere of LP 791, 18 with the James Webb Telescope, thanks to which it will be possible to learn more about the planet. The James Webb Space Telescope is now practically the world's premier space observatory, allowing us to peer into distant worlds around other stars, explore mysterious structures, and learn more about the origins of the universe and our place in it. So far, nearly 6,000 exoplanets in 4,000 star systems have already been confirmed, with several thousand more candidates awaiting verification. Of course, the public's attention is focused on planets that are as Earth-like as possible. We have not given up hope of finding intelligent life in space. However, the bulk of distant worlds look very strange to us. There are often conditions there that we can't even imagine. After all, science fiction writers have long advised people not to fixate on our carbon-based form of life. There may be much in the universe beyond our understanding, but science exists to push those boundaries. The properties of light and its impact on our lives never cease to amaze us. Light, or electromagnetic wave, plays a central role in many aspects of our lives and is a key concept in physics. Fundamental questions such as the interaction of light with matter, the propagation of light waves, and the transfer of energy have been the basis for many important discoveries and theories of physics. But if light is a type of electromagnetic radiation that is usually associated with the visible part of the spectrum, what can be said about a concept like darkness? More precisely, the concept is there, but is the phenomenon itself there? Even if you turn off the sun, the Earth will not plunge into total darkness. Light from stars, nebulae, and even the Big Bang itself will illuminate your sky in this case. The planet itself and everything on it, including our bodies, also emit light, and it will be visible in the infrared. Even if you somehow found a way to turn off the sun, even then it will emit a certain level of light, almost forever. There's enough for our age, and for many centuries to come. But of course, it will be eerie to realize the eternal cold. So as long as we can see, we'll see. No optical sensor can detect total darkness. Or take black holes, the darkest of the supposed objects. Even they are capable of emitting some percentage of light, according to some theories. In physics, unlike in the realm of interpersonal relationships, light always defeats darkness. Electromagnetic waves are a collection of alternating electric and magnetic fields that propagate through space at a specific frequency and wavelength. The spectrum of electromagnetic radiation includes, in addition to visible light, radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. Yes, light plays an important role in physics because of its ability to interact with matter and change its properties. When light particles, photons, are absorbed, atoms and molecules move to higher energy levels, which can cause chemical reactions, thermal radiation, changes in the state of matter, and even nuclear reactions. Where does light itself come from? Let's take the example of the emission of light by the sun. In our star, numerous chemical and thermonuclear reactions take place, which are accompanied by the emission of quanta of light. When two hydrogen atoms collide, they combine to form one atom, called deuterium, which is lighter than the atoms from which it was formed, and the extra energy is released as a photon. Deuterium, in turn, joins one more hydrogen atom, and helium. 3 is formed, and one more photon is released. When two helium, 3 atoms collide, helium, 3 atoms collide, helium. 4, 2 hydrogen atoms, and one more photon are formed. So, the sun from 4 hydrogen atoms produces one helium atom and 3 photons, and that's just from one chain of reactions. Each of these photons carries a large amount of energy, and for tens of thousands and millions of years, wanders inside the sun, colliding with atoms, heating up the sun, and turning into dozens of photons with less energy and frequency, visible to the eye. Sooner or later, these photons fly out of the sun and go on a long and sad journey through space, and some of them come to Earth, giving us light and warmth. So what are the physical characteristics of light? First, it is speed, one of the most important fundamental constants in physics. In a vacuum, it is equal to almost 300,000 kilometers per second. What about the speed of darkness? How fast will the eerie darkness descend upon us? The simplest answer is that the speed of darkness is the same as the speed of light. Turn off the sun, and our sky will be dark 8 minutes from now. What we used to call the speed of light is the speed of propagation, and it is not always the deciding factor. The shadow that falls across the landscape is cast by objects, and the feature of those objects and the distance from them will determine how fast it falls. For example, a rotating lighthouse searchlight illuminates the surroundings at regular intervals. However, the relative rate of dimming of the surroundings increases with increasing distance from the lighthouse itself. If you move far enough away from the lighthouse, the shadow will catch up with you faster than the speed of light propagation. Isn't that right? The same thing happens with neutron stars in space, for example. In other words, in this case, the speed of light will only mean a delay. Even if the beacon is pointed directly at you, you will see the light. Not immediately, but with some delay. However, this will have no effect on the course of events that you will see when you are in your position. In any case, you have been detected and have nowhere to run to. Moreover, light has an inherent wavelength. The spectrum of visible light is just the part of the electromagnetic spectrum that the human eye can see. The cone-shaped cells in our eyes act as receivers tuned to wavelengths in this narrow band of the spectrum. Other parts of the spectrum have wavelengths that are too large or too small and energetic for us to see. When objects get hotter, they emit energy, dominated by shorter wavelengths, changing color before our eyes. The flame of a blowtorch changes color from reddish to bluish as it is set to burn hotter. In the same way, the color of stars tells us their temperature. Our sun emits more yellow light than any other because its surface temperature is 5,500 deg. If the sun's surface were colder, say 3,000 degs, it would look reddish, like the star Betelgeuse. If the sun were hotter, around 12,000 deg, it would look blue, like the star Rigel. Reflection, refraction, and absorption of light are the basic processes that occur when light interacts with matter. Let's break each of them down a bit. Reflection is the process by which light reflected from objects hits the smooth surface of a mirror and is then reflected back, giving us an image of the object. That is, the angle of incidence of light is equal to the angle of reflection. Further, refraction of light is a phenomenon in which light rays change their direction of travel when passing from one medium to another with different densities. This causes objects in water to appear displaced or distorted compared to their position in the air. This is why faces in water are so creepy. Finally, absorption is the process by which light hitting the surface of an object is converted into another form of energy, such as heat. This occurs due to the interaction of light waves with material particles. For example, when an object is illuminated with blue light, the object may absorb all the blue waves and reflect red and green waves. As a result, the object will appear greenish. Red will appear greenish, red. This explains why objects have certain colors. They absorb some light waves and reflect others, and is not the work of sorcerers. So, the interaction of these three processes determines how we perceive light and see objects in the world around us. Reflection and refraction form the images of the objects we see, while absorption determines their color and brightness. Unlike light, darkness is not a physical category, but rather a relative state. It's not even that. It is a subjective perception of the state. Photons may or may not be reflected. Retinal cells may trigger memory processes, but cannot explain the subjective experience of darkness. Just as waves cannot be represented by anything more than our experience of color or sound. Our subjective experience changes from time to time, but the individual parts of that experience lie outside of time. And in this sense, we can say that darkness itself has no speed. What is speed in the common understanding? And does it exist at all? It presupposes in advance the existence of some space in which it can be measured. However, in the world of quantum physics, where the familiar concepts of conventional physics often become useless, it is believed that space itself is one of the derivatives of a more fundamental level of reality, where there are no such concepts as position, distance, or speed at all. In conclusion, let us try to draw some conclusions and clarify how important and inseparable all the properties of light are. We already know the basic characteristics of light. It is a form of electromagnetic radiation, consisting of photons, and has the ability to propagate in a vacuum at a constant speed. At the same time, light is often described in terms of its dual nature, having the properties of both waves and particles. This unusual property is not only striking and surprising, but is also an important key to understanding fundamental mechanisms in quantum mechanics, as well as phenomena such as interference, diffraction, and polarization in light. Light also plays an invaluable role, not only on our planet, but in the universe as a whole. Its ability to deliver information from the farthest reaches of space, to create conditions for life on Earth, and to serve as a tool for studying and understanding the world around us, makes light a true magical phenomenon. We owe it to light for the ability to see and perceive our surroundings. It allows us to admire the beauties of nature, distinguish colors and shapes, and facilitates our social interaction and communication. Thus, whatever light is by nature, it is one of the most amazing phenomena ever discovered by mankind. But the question of how light originally came to be remains open.